Okay, today is November 14th, 2024. We will talk about convergence of sequence today. I will share the note we did. I will carefully read it. First, we will talk about convergence of sequence. We first define a sequence. Sequence is a function that goes from natural number to real number. Instead of using function notation, the value of the sequence are denoted by n equals to 1 to infinite. We call this as sequence, and there is a no mm, over right. That is sequence, and there is convergence of sequence, which is for every epsilon zero, some epsilon n, which is n, such that this, if it satisfies that difference between an minus l is smaller than l epsilon, then we will say a real sequence is converges. I will write it. The important thing is it is exists in every epsilon zero. So we should write first every epsilon zero. Epsilon which is big, every epsilon which is bigger than zero. And for some epsilon, so for some n, which is in natural number, then when n is bigger or same than n, then there is an minus l. The difference between an minus l is smaller than epsilon. Uh, I have no intuition right now, but the thing is, for every epsilon, for each number in a sequence, uh, if it satisfies this, we will say it is converged. The real number L, R, which is element of R, is called the limit, and when a sequence an has the limit, we will use this notation and we will say it is converged. So we learn this term in calculus. We will more rigorously define it. Right. I don't know how can I erase this so I know. Mhm. When n goes to infinite, an equals to n. If is the sequence is converges, we will more rigorously define every when epsilon is bigger than zero and some n, which is natural number, if that satisfies and we will say it's converge. So if not, then we will say divergent. It is divergent. Limit an, which is if an is 1 over n, we will say it is convergent. We will prove it with Archimedian property. Let epsilon is bigger than 0. And for this, we can sum n. We can make some epsilon multiple n is bigger than 1. Then we can get this inequality. Then if we assume n is bigger or same than n epsilon, then an minus 0 is bigger or same than 1 over n and smaller than epsilon. So it will converges to zero. And the other thing example is it differs. Uh, in this note, we say when we define it, uh, when it becomes two, it will be odd number case, and there will be even number case. We will suppose it will converge, then it should satisfy this inequality. But in case one, in case two, uh, the range between B becomes different, so it will be not converged. And we can actually in this case, he said this is epsilon 1, but we can do it when it is epsilon 1.5. And maybe also in the case it is 2. And we are learning about absolute value here. Next time we will learn about triangular inequality and limit theorem. Okay, today we finished our study. Do you have any questions or comment? Ina, do you have any questions or comment? No.
No, I don't have.
Okay. Jonathan or Tobias, do you have any comment?
For me, it's fine.
Okay. Jonathan, do you have any comment? Okay, there's no comments today. Okay, thank you very much.